I actually provide a mathematical way of justifying statistical inference. You know, uh, E provided, okay, mathematical mathematical way of justifying statistical inference. Now, Reverend Thomas Bayes actually believed that we normally start with a prior belief. Prior belief. Okay, what do I mean by prior belief? He attached a probability to this. We call it prior probability. This actually means the state of nature before collection of data. Okay, state of nature before seeing data or before seeing evidence. Okay, that's what we call prior belief. Our mind can never be empty. We're always going to believe on something. Okay, now uh, the next one is what we call the likelihood. The likelihood is more. The likelihood is going to come in form of a conditional probability. The prior belief does not come in form of a conditional probability. But because your belief is not on anything, you don't have nothing to show because you have not actually collected data. Okay, but the likelihood belief is actually going to come with evidence, with data. Okay, now if you take a look, so which I call the evidence. Okay, now finally, we're now going to have posterior. Okay, we're going to have posterior. Now, Reverend Thomas Bayes became important, became relevant because he believed that if we start with a prior belief, the moment evidence, new information is available, we can update our belief. Updating our belief, then we're now going to have a posterior belief. So posterior, we got posterior combining the prior belief with the likelihood. The likelihood is the evidence. Does that make sense? That is the idea. Now, I'm now going to go into the real life application. Now you understand what Reverend Thomas Bayes was trying to pass across. Now, number one, I want to talk about medical diagnosis. Okay, this is number one area of Bayes' theorem. Now, when you talk about medical diagnosis, we got a situation whereby maybe some people have disease and we want our equipment to detect that, and the equipment that we have is not 100% efficient. Okay, there could be some errors of diagnosis. Okay, now what we want to do, so we want to figure out what is the probability, okay, that a particular patient has a disease giving a positive result, giving positive results. Now, if you take a look at what I have here, okay, this is the patient right now, and they've run tests on this guy, and the machine said the disease is present. Now we want to figure out what is the probability that disease is present, given, because let me tell you this: why can't we just like go straight, like believing on the equipment? The reason why we're not going to believe totally on the equipment because the efficiency of that equipment is not 100%. Does that make sense? Now, if you take a look at this right now, this is going to be the probability. Okay, you're gonna take. I need you to pay attention now. I'm gonna switch this. Okay, now it's gonna be the probability of positive given disease multiplied by probability of disease divided by probability of positive results. Please, I need you to pay attention. Okay, you're going to see the Bayes theorem is going to play out right now. Now, the question now is, what is the difference between this guy and this guy? Please pay attention. What is it different? I need you to pay attention. This guy is a prior before collection of data. What is my belief about the prevalence of the disease? I've not collected data at all. Okay, the prevalence. This guy is a likelihood. This guy is a likelihood. Okay, now let me tell you the difference between this guy and this guy. This guy is trying to say, I know this guy has the disease. I know, we know, it's true that this guy, disease is truly present. And this guy, what is the probability that the machine will detect that? Which is this guy. Disease is present. And we want to figure out the probability that the machine is going to, tell us positive. But this guy, machine told us somebody is positive. Then we want to figure out what is the probability that disease is present. This is different from this. Do you see that now? The two are not the same. Now, when you take a look at this denominator here, please pay attention. This denominator here means the probability of positive result. Somebody could have a positive result. Now, this guy can be broken into two because somebody could have a positive result and disease is not present, or somebody could have a positive result and disease is present. Does that make sense? Now, if I want to rewrite this now, okay, this particular guy here is a member here. So I'm actually going to write the probability of positive given disease, okay, multiplied by probability of disease. So if I want to write the probability of the positive result, I'm going to write the whole thing. I'm going to have the probability of positive given disease, okay, multiplied by probability of disease, plus the probability of positive, okay. Now, here, disease. The other one is not going to be disease, it's going to be disease complement. Okay? Maybe I'm going to say 80 multiplied by probability of 80. Look at that. So which means this guy here is the total probability that we talk about. Does that make sense? So this is it. So combining, so this guy here, like I said, is the posterior, which is what the distribution, the probability that we got after updating our prior belief with the evidence. The evidence, the likelihood we believe is the evidence. Does that make sense? That is exactly what we mean here. Now, this is in medical diagnosis. I'm actually going to show you another application now. Now, I want to go to forensic analysis. We're going to assume we're in a court of law. Okay, another application, forensic science. Okay, now, if, somebody is guilty, they normally, let's say we have a suspect. Okay, suspect should be presumed innocent until proven guilty. You understand what I mean? Okay, now, we want to figure out what is the probability that a suspect is guilty, okay, given the evidence. Okay, right now, I'm actually, G represent guilty, E represent evidence. Now, if I want to rewrite this, I'm actually going to switch it. I'm actually going to have E given G multiplied by the probability of G, or divided by probability of evidence. The probability of evidence is going to be a total probability. Now, this is prior. Do you know the belief? Because the prosecutor believes that the accused is guilty. That is their prior belief. That's why this is, you can see, the prior belief is not a conditional probability. But the likelihood and the posterior, they are conditional probability. Does that make sense to you right now? Okay, now, do you know what this guy is trying to say? Okay, we've seen evidence. What is the probability that the accused is guilty? But when you take a look at this guy, okay, when accused has been found guilty, what is the probability of the evidence? This is not the same as this. And when you take a look at this now, if I want to rewrite this, I'm actually going to write this multiplied by this. This guy, so it's always a member of this guy. So I'm actually going to write E giving G, the probability of G, plus I'm going to write E giving now guilty. I'm actually going to add the complement of guilty multiplied by the complement of guilty. Take a look at that. This is Bayes' theorem now. Is there any question here?